Hello, welcome back to another lesson. Today we are going to look at using equations as point testers. So let's look at this graph right here that is in pink. This is the graph of the equation 2x plus 3y equals 12, and you can see it is a line. Now, on our coordinate plane, there are several points, and we are going to look at the point negative 1, 8. Is negative 1.8 on the graph? Well, clearly, you see that negative 1.8 is not on the line. But we want to explain using the equation. So what we're going to do is we are going to use the coordinates from that point, and we are going to substitute the values into the equation. Think back when we talked about solving a linear equation, and a solution of an equation is a value that satisfies the equation. So think of it like that. If we want to test whether a point is on the graph of an equation, we want to see if its coordinates satisfy the equation of that graph. Okay, so remember the first number in the order pair, that's your x value. So we're going to replace x with negative 1, and we're going to replace y with positive 8. Then we put the question mark above the equal sign, because right now we do not know if both sides are equal to each other. Now let's evaluate. 2 times negative 1, that's negative 2. 3 times 8, that's 24. We have negative 2 plus 24, that's equal to positive 22. Now it's obvious that 22 does not equal to 22 does not equal to 12. Therefore, we say that negative 1.8 is not on the graph because it does not satisfy the equation. Okay? So the definition that we are going to write down today is point tester. Notice how we highlight the word equation. That's what a point tester is. It's an equation that we use to verify if a point is on the graph of a given equation or not. This means the graph of an equation is a collection of all points with coordinates that make the equation true, just like what we discussed earlier. All right, now we're going to do a couple of examples, writing equations with some special lines. So let's go through this one. It says let q equals 3 negative 5. And let me open this working window for us. All right, so let's plot 3 negative 5 on our graph. Pick the color, and here you go. So 3 negative 5. All right, that's our point, and we're gonna label it Q. It says line H is horizontal and passes through Q. Write an equation for H. All right, remember, we know that horizontal is a line that goes left and right. Okay, so see if I can. Oh, there you go. Sorry about that. It's not a straight line, but all right. What we want to do is let's pick some points that are on this line. Okay, so let's pick this point right here. Oh, let me go back. And let's find the coordinates for that point. Well, let me see. 1, 2, negative 2, negative 5. And next, let's pick this point right here. All right, we say 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's positive 9. and still negative 5. We'll do one more point and we'll see if we can figure out the pattern. We'll put this point right here. So 1, 2, 3, 4, 5, 6, 7, 8. We have negative 8 and negative 5. What do we notice about the coordinates of these 3 points that are on the horizontal line that goes through our point Q? Good. Hopefully you saw that all of the y coordinates or the y values are equal to negative 5. Well, how can we write an equation that says all of the y coordinates are equal to negative 5? That is our point tester or our equation. Pretty simple? Cool. All right, well, let's do another one. Okay, let me go to the screen. Here we go. This time we're going to have the same point Q at 3, negative 5. So 3, 2, 4, 5. Okay. And instead of having a horizontal line, we're going to have a vertical line that passes through Q. So let's see if I can draw a better line. There we go. And we're going to do the similar steps as last time. We're going to pick some points. Oh, excuse me, I forgot to change the setting. Alright, let's pick this point right here. And that's 1, 2, 3. 1, 2, 3, up 3. Okay. Let's look at this point right here. 1, 2, 3, down 2. And one more. This one right here. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, negative 8. Okay, do you see the pattern yet? Looks like all of the x coordinates are equal to 3. So then how can we write an equation? X equals to 3. That is our equation. Alright? We're going to do one more example that deals with using equations as a point tester. And this is a really good question. It says, which point is not on the graph of 5x plus 6y equals negative 42? So as you remember what we need to do? Okay. Well, if you remember, see if you can do this on your own. And when you're ready to check the answer, you can continue the video. Alright, well, we said earlier, if a point is on the graph of an equation, it means that the coordinates must satisfy the equation. So we're going to test all 4 of these points and find the ones that does not satisfy the equation of 5x plus 6y equals negative 42. Alright, so remember the first number is your x, the second number is your y. So we have 5 times 6 plus 6 times negative 12. We want to see if it's equal to negative 42. So we have 30 plus negative 72. We want to see if it's equal to negative 42. And what do we have? We have 30 plus negative 72. That's equal to negative 42. And negative 42 equals to negative 42. Yes, so this equation checks out. Okay, so this is yes. Let's do B. 5 times negative 12 plus 6 times 3. We want to see if it's equal to negative 42. 5 times negative 12, that's negative 60. Plus 18. Is that equal to negative 42? Looks like it does. So negative 42 equals to negative 42. Alright, so this point is on the graph Alright, next one. 5 times negative 9 plus 6 times 0.5. And we want to see this equal to negative 42. Okay, 5 times negative 9, that's negative 45. 6 times 0.5, that is equal to positive 3. Negative 45 plus 3, that's negative 42. And it does satisfy the equation. Well, through process elimination, we know that D must be the point that is not on the graph of the equation 5x plus 6y equals negative 42. But we just want to be sure, because sometimes we can have trick questions and it could be that all the points are on the graph. So let's check D. We have 5 times 4 plus 6 times negative 10. We want to see if it's equal to negative 42. 5 times 4 is 20. Plus 6 times negative 10 is negative 60. We want to see if it's equal to negative 42. 20 plus negative 60 is negative 40. And does negative 40 equals to negative 42? No. So clearly we see that this point right here is not on the graph of that equation. Hopefully, after watching this video, kind of refresh your memory of what we talked about in class, and hopefully you will be able to do the assignment now. Alright, thanks for watching.